Hello and welcome. In this video, we're going to walk through the process of building a signal chain in ADIsimRF, an easy-to-use RF signal chain calculator. So we are going to start on the home screen of ADIsimRF. There are a number of ways to add devices to the signal chain. If you know the device you want to add, you can easily load it using the pull-down menus. Let's say we want to make a 6 GHz receiver that uses HMC 8410 and broadband LNA. Firstly, we switch into the receive mode by clicking on the Transmit Receive toggle button. Next, we click on the device pull down and find LNAs. Then we hit the Tab key. Next, we click on the part number pull down and find the HMC 8410 and again hit Tab. Now we have to tell the program the operating frequency for HMC 8410. So we type 6000 into the frequency window and hit Tab. This causes the stage to fully populate. Next, we will add the HMC 1018 digital step attenuator in the second stage. So we select the DSA device type and scroll down until we find HMC 1018. Next, we would like to specify the attenuation setting for the DSA using this pull down. But before we can do that, we need to specify the frequency. So we type in 6000. And we see that the gain pull down is now enabled. So let's choose minimum attenuation. And once we do that, we see that the stage populates with noise and distortion data. An alternative approach to device selection is to use the device selection wizard. This is useful if you know your target specs, but you don't know which device to use. So we click here to open the device selection wizard. Next, we specify device type and frequency and hit Find Devices. And we see HMC 1018 appear in the table, which we then select and insert into the signal chain. In addition to choosing devices from the library, you can also define your own devices by typing in data directly on screen. For example, if we want to make a passive filter, we can select bandpass filter and then enter our own data. So let's select a bandpass filter. Let's enter a center frequency of 6000. Let's give it an input impedance of 50 ohms. And let's give it an insertion loss of -1 dB. One thing to note when you're entering data for passive devices, the noise figure field does not automatically populate when you enter insertion loss, so you have to type that in separately. So you can proceed like this until the complete signal chain is built. Once that's done, the last thing you need to do is to adjust the settings in the input box. The number of stages is 10 by default, but you can increase this to a maximum of 50. Input power in dBm is the drive level into the first device in the signal chain. The analysis bandwidth or channel bandwidth is used for noise and SNR calculations. PEP to RMS ratio is the peak to average ratio or crest factor of the input signal. This is useful for peak-to-peak voltage calculations. And these back-off warnings, one for peak and one for average power, define when alarms should indicate that the RF power level of a device is coming close to the compression point of that device. Once you have built, configured and simulated your signal chain, you can easily save it or share it with a colleague using the save function. And the file is saved with a .sgc extension. This file can be shared with colleagues who can load it into their own ADIsimRF installations. Thank you for taking the time to watch this video. For more information and to download ADIsimRF, please go to analog.com/ADIsimRF.